Now it's time for 10-4 number 15, which is going to be a two-tailed test. This is saying 52% of parents of children in high school felt it was a serious problem that high school students were not being taught enough math and science. We have this recent survey, blah, blah, blah. Aha. Do parents feel differently today than they did in 1994? Differently, meaning either way, left or right, higher, lower. So let's make ourselves a little copy and paste action. Let's go, either one of the old ones will work. I'll pick the upper one. That's the one we did most recently. Why not? Not going to hurt us. So let me go in here, paste. Oopsie. Copy. Something messed up there. Paste. There we go. All right, let's see here. We have 0.52. You got to turn that percentage into a decimal. Alpha is 0.05. That's great. We got 256 out of 800. Don't forget that x has to be smaller than n in order for p hat to make any sense. So if you're faced with two numbers, 256 and 800, the bigger one's always the n, 800, and the smaller one's always the x. All right, now since we copied and pasted, looky there, our square root of b1, 1 minus b1 over that's all still set up perfectly for us. All right, we need two critical values here, so I'm going to highlight these two cells. I'm going to insert, right click, insert, shift the cells down, and I'm going to, hey, I'm going to be even craftier than I normally am. I'm going to go copy and paste in. Hey, looky there. Okay, now this is going to be slightly different. This is alpha over 2, not alpha. That's because this is a two-tailed test. So you better go in here and change these to alpha over 2's. Which makes me wonder, did I do that? Oh, look at that, I didn't. That was bad of me. Those were alpha over 2's back there. Right, two-tailed test always is alpha over 2. Sorry about that. Okay, so that means in here I'm going to have to do alpha norm S inverse of alpha, which is 0.05, cut in half, divided by 2. And then I got to do the same thing here. 1 minus alpha divided by 2. Alpha being in cell B2. There we go. Now I've got my two critical values. Now my test statistic, the formula has not changed in all of chapter 10. It's still standardized. B5, which is 0.32, comma, B1, which is the 0.52, comma, the standard error right here, standard deviation of the sampling distribution of sample proportion. Sigma p hat, in other words, that one. Now, this formula right here doesn't work for two-tailed tests. It only works for one-tailed test. Remember, I had to add in that correction, in case you'd forgotten. I had to add a correction to 10.2. Let me go back to it right here. Oh, whoops, sorry. 10.2 number 25. I have to use this formula right there. 2 times 1 minus norm S dist of the absolute value of D11. That's the way two-tailed tests are going to have to work with z-scores. So I'm going to have to do that here. So 2 times, parentheses, 1 minus norm S dist of this score right here. That's the test statistic. Oops, sorry, not of that, ABS of that. I need the absolute value of that score. So it's 2 times 1 minus the norm S dist of the absolute value of the test statistic. Enter. It's 0. Now I know what you're thinking. You're thinking, well, that doesn't seem right. It is right. Look, you are 11 standard deviations away from the mean. Think about that, right? 11 standard deviations away. So what's the probability of you being off in the tails, both tails, right? Negative 11 and positive 11. Really, really, really small, because there's almost no area in those tails. Since the chances of you getting this by accident are super low, right? It's not really 0, but it's like 0.0000000, lots and lots of zeros and then some number. Since that's so low, we are going to reject H naught, right? Because P equals 0 is less than 0.05, which is alpha. Now we know in real life it's not really 0, but the computer can't figure it out because it's so low. In other words, we're rejecting H naught because Z0 equals negative 11.3 is lower than negative 1.95.